Today we'll be looking at series. So we'll be looking at those questions there. The first question we have to show that the sum of the first n natural numbers is n into bracket n plus 1 divided by 2. To establish this, we have to consider, because what this will actually mean is that we want to show that 1 plus 2 plus 3 plus dot 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 plus n is equal to n into bracket n plus 1 upon 2. So we need to consider this, the expansion of r plus 1 whole square. So when we consider this, because we said we want to look at the sum of the first n natural numbers, and for these numbers their power is 1, positive 1. So we'll consider when the power is 2 for r plus 1, like a value that is more than a single value. Like if you have ordinary r, you could represent what we have, because this summation 1 plus this to this simply represents summation of r from r equal 1 to n. So this one is r, like our TR here represents r. So if you want to establish the rule, rather consider the next term after this, which is going to be r plus 1 to the power of 2, because this r is having power 1. So the next term to this, that is more than this, will be r plus 1. But the power that one will be having will be 2, will be 1 more than this. So when we look at the expansion of this, we have it to be r squared plus 2r plus 1. So if this one plus to this side, we have r plus 1 whole squared, negative r squared equals 2r plus 1. So from here, if we want to establish what we want to establish now, we'll put in r to be equal to 1, 2, 3, comma, dot, 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 comma, we have n negative 1, and lastly n. So of course, if I put r to be 1 into this, I'm going to have 2 squared minus 1 squared to be equal to 2 into bracket 1 plus 1. And when I put this next value of r, I'm going to have 3 squared minus 2 squared equal 2 into bracket 2 plus 1. When I put r to be 3, I'm going to have 4 squared minus 3 squared equal 2 into bracket 3 plus 1 plus dot dot dot. Now when I now put r to be n minus 1 into this, I'm going to have n squared minus n minus 1 squared equal 2 into bracket n negative 1 plus 1. And lastly, when r is equal to n, I'm going to have n plus 1 whole squared negative n squared equal 2n plus 1. So when we consider the summation of what we have here, when we consider the addition of everything here, this we cancel this we cancel this. Likewise, there is a term that will cancel this. So that is how the term continue. So something we actually cancel, this one we cancel this one. Something that cancel this one in between. So we'll be left with this one, n plus 1 squared minus 1 squared, which is 1. So it's equal to, looking at what we have here, for this first term, 2 is common to each of the terms. So if 2 is out, we are going to have 1 plus 2 plus 3 plus dot 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 plus this n negative 1 plus n. And for this one, we have 1 being added to himself in n places. So we can simply put down as 1 time the number of times we have it being repeated. So we have n plus 1 whole squared minus 1 to be what we have here. I can simply down as summation of r from r equal to 1 to n plus this time is n. So when I expand this one, I have it to be n squared plus 2n plus 1 negative 1 equal to summation r equal to 1 to n r plus n. So when this one moves to this side, I have n squared plus 2n negative n. This one is out. So we have to summation r equal 1 to n of r. So this one we cancel. This one, when we subtract from this, we'll be left with n squared plus n equal to summation r equal 1 to n of r. So this, one factorize, so we are going to have summation 2 summation of r equal 1 to n of r equal 1 factorize, then the common when we factorize n out, we have n into bracket n plus 1. So when we make this result there, we have summation r equal 1 to n of r to be equal to n upon n plus 1 upon 2. But we know that this summation simply represents addition from year to year. So we have 1 plus 2 plus 3 plus dot 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 plus n to be equal to n into bracket n plus 1 upon 2. And that is the proof of the first question. For the second question, we have to establish that the sum of the square of the first n natural numbers is n into bracket n plus 1 divided by 2n plus 1 upon 6. And what that simply means is that 1 square plus 2 square plus dot 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 segregate to n square is equal to that. So if we establish this, since what we have there, this series simply means summation of r equal 1 to n of r squared. So we are going to consider the next term to this r, that is a value that is more than this, and that one is going to be r plus 1. So this power 2 will be increased by 1. So it's going to be r plus 1 cube that we are going to consider in order for us to be able to establish that this is summation of going to give this. So when we consider r plus 1 cube, the expansion is r cube plus 3r squared plus 3r plus 1. So when this one goes to this side, we have r plus 1 cube negative r cube equal 3r squared plus 3r plus 1. So when we putting r to be 1, 2, 3, dot dot dot, comma, n negative 1 and n. So as for when we put r to be 1, we have 2 cube minus 1 cube equal this. And now when we put r to be 2, we have 3 cube minus 2 cube equal 3 into bracket 2 square plus 3 times 2 plus 1. When we put r to be equal to 3, we are going to have 4 cube minus 3 cube equal 3 into bracket 3 square plus 3 times 3 plus 1 plus dot dot dot, and when we put r to be equal to n negative 1, we are going to have n cube minus n negative 1 cube equal 3 into bracket n minus 1 square plus 3 into bracket n minus 1 plus 1. So when we put r to be n, we have n plus 1 cube minus n cube equal 3n squared plus 3n plus 1. So when we consider the summation of what we have there of these equations, we will discover that this will cancel this, this will cancel this. There will be a term that will cancel this one. Likewise, there will be something that will cancel this. So in the long run, we will be left with this and this, because this also cancel this. So we have n plus 1 cube minus 1 cube, and 1 cube is same thing as 1 equal 3. Now, looking at what we have here, the first time, you see that 3 is common. So we can factorize the 3 out. When the 3 is factorized out, we are going to have 1 squared plus 2 squared plus 3 squared plus dot 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 n negative 1 squared plus n squared. And for this next term, you see that what 3 is also common. We can factorize that out. So we will be having 1 plus 2 plus 3 plus dot 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 plus n in bracket. And we have 1 being added to himself in n places. And that one simply means that 1 times the number of times being added. So that is 1 times n. So this one, when we expand, we have n cubed plus 3n squared plus 3n plus 1 negative 1 equal 3. This one simply means summation r equal 1 to n of r squared plus 3 plus 3. This one simply means summation r equal 1 to n of r plus this time is n. So this cancels it. We have n cubed plus 3n squared plus 3n equal 3 summation r equal 1 to n of r squared plus this one we evaluated that before, and we have the value to be n into bracket n plus 1 upon 2. So we have 3n into bracket n plus 1 upon 2 plus n. So when we transfer these two to this side, we have 3 summation r equal 1 to n of r squared equal n cubed plus 3n squared plus 3n, this one to this side minus n, and this one minus 3n into bracket n plus 1 upon 2. So we are going to have it to be equal to n cubed plus 3n squared. This and this will give us plus 2n minus 3n squared plus 3n upon 2. So when we find the LCM, we have 2n cubed plus 6n squared plus 4n negative 3n squared minus 3n. And this will reduce to 2n cubed plus 3n plus n upon 2. And looking at the numerator, something is common, which is n. If n is out, we have 2n squared plus 3n plus 1 upon 2. So looking at the expression in brackets, it is factorizable. 2n squared plus 3n plus 1 is the same thing as 2n squared plus 2n plus n plus 1. So looking at these two terms, the common factor is 2n. So we have n plus 1, and this common factor is plus 1. We now have n plus 1 in bracket. Since this and this is the same, so the number outside the bracket will go into a bracket times one of these that is common to the two, n plus 1. So we now have the summation of r squared from r equal to 1 to n to be equal to n into bracket. I can put this one first. This times this is still that this times this. So I can put it as n plus 1 times 2n plus 1 upon 2. So when we will divide both sides by this 3, we are going to have summation r equal 1 to n of r squared to be equal to n into bracket n plus 1 times 2n plus 1 upon this 3. When it will live here, is going to multiply this 2, so we have 6 here. So that is what the proof for the question 2. So this is a PQ question, a practice question. You have to show that the sum of the key of first n natural numbers is equal to n plus n into bracket n plus 1 upon 2 all squared. So if you want to do this based on what we discussed earlier, this is the hint you are going to use. And please try to subscribe, share, and like